Hello, and welcome to Nexstara's video series on the Salesforce Developer Workbooks. In this track, we'll be walking you through the Apex Workbook. This video covers Chapter 2, Tutorial 7, Classes, Interfaces, and Properties. Apex is an object-oriented programming language. In this tutorial, we will examine Apex's support of the fundamentals of object-oriented programming. We're going to be talking about the following: classes and objects. A class is a template of a data structure, and an object is the implementation of that template. Private modifiers. A private modifier restricts access to a class or a class method or a member variable contained in the class, so they aren't available to other classes. Static variables, constants, and methods. Static variables, constants, and methods don't depend on an instance of a class and can be accessed without creating an object from that class. Interfaces. Interfaces are named sets of method signatures that don't contain any implementation. Properties. Properties allow controlled read and write access to a class member variable. To begin, log into your Salesforce developer account. Under your name, go ahead and open up the developer console. Once in the developer console, go ahead and click under File, New, Apex Class. For the name of our class, we're going to call this Fridge. So classes in Apex are similar to Java classes. A class is a template or a blueprint from which objects are created, and an object is an instance of a class. Here's an example of a very basic class. So this is a class for a fridge, and it has a model number, a number of fridges in stock, and a method that lets you update the number in stock. So if you say you pass it a number just sold, it'll subtract that from the number in stock, and that'll be the new number in stock. So a very basic class. Now these two variables here, the model number and the number in stock, are variables associated with this class. We call those member variables. They help control the state of the class. And this right here, this update stock, is a method. And methods are used to control the behavior of classes. Methods also contain local variables that are declared inside the method, such as this just sold parameter. Local variables can only be used within the method they're declared in, unlike class member variables that are persistent with the instance of the class. Now that we've got our new fridge class, we can go ahead and File, Save. And let's go ahead and create some instances of a fridge. So in the developer console, go ahead under Debug and open Execute Anonymous window. In the code box here, I'm going to go ahead and enter this test code. Now just to walk you through what this does, first we're going to declare fridge and create a new instance of fridge called myFridge. And myFridge's model number is MX-O. The number in stock of myFridge is 100. And then we're going to call update stock and pass the number 20 to it. So if we do that, that should reduce the stock to 80 for myFridge. Now we're going to create another new instance of fridge called myOtherFridge. That model is MX-Y. And we're going to set the stock to 50. And then we're going to print the number in stock of each. So let's go ahead and execute that and see what we get. We should see two debug statements. We got myFridge, which has a number in stock of 80, and myOtherFridge has a number in stock of 50, which is exactly what we expect. So that's a pretty basic example of a class with some member variables, a method, and some local variables, kind of how creating and working with classes works. The next thing we're going to talk about is access modifiers. You may notice in this example class that everything is prefixed with the word public. Public access modifier ensures that other Apex classes can directly manipulate these variables and call these methods. That's what public allows. Now, sometimes you may want to restrict access to certain variables and methods from outside objects. We do that by declaring variables and methods with the private access modifier. Now, the model number and number in stock variables are private and can only be accessed from within the fridge class itself. So we can demonstrate what that means. If I go back here, and I'm only going to run these first two lines. So we're going to create a new fridge and we're going to attempt to set that fridge's model number. We'll see what happens. There we go. Variable is not visible, model number. So that means that trying to call this variable directly and assign it a value is not allowed because it's now private. Now, sometimes you want to provide access to private variables through getter and setter methods that are commonly called properties. We'll cover that a little bit more in lesson 6. Now, what we can do to allow visibility to those variables, we can use the following methods. One set model number and one get model number. And all that allows is one sets the model number based on a parameter string and the other one just returns the model number. Now, you may look at this and ask, why not just make the variables themselves public? Sometimes you may want to do some sanitization of input and maybe you want to be maybe you want to do some pre-processing to a value before it actually becomes assigned to a variable in your class. You may want to do lots of things before they actually become variables, and you can use these getter and setter methods as gatekeepers to your variables and make sure that they all have the values that you expect. So now with these two methods available, let's go ahead and save it. And let's make a little change to our earlier example and see how that works. So rather than setting the model number directly, we're going to use the set model number method. Set that to a value, and then we're going to call get model number and print that to the debug log. So let's go ahead and run that. There we go. So that worked. So there's a short example of how access modifiers work as far as public and private. The next thing we're going to talk about are constructors. Constructors are special methods included in a class that run at the time that the class is instantiated. Apex has a special default constructor for all classes that set every value to null. That's more for security and stability than anything else. You can always tell a constructor from any other method because it has the same name as the class itself. For example, you would declare a constructor for this class like this. The constructor always has the same name as the class and it has no return type. That's how you can tell it's a constructor. We're going to go ahead and add a custom constructor to our class. And so in our new constructor, it sets the model number equal to xx-xx and sets the number in stock equal to 0. And this will run as soon as we do something like this. As soon as we call new fridge with no arguments, then this method runs. Now, it's common to have multiple constructors depending on how a class is instantiated. So, for example, we could do something like this. Now, this constructor is accepting two arguments. It's accepting a string with, calling itself the model number and an integer for the number in stock. And all it's doing is setting the values in these arguments equal to the values in the member variables. So this allows you to, at the same time you instantiate the new fridge, you can also set the model number and number in stock at the same time. Now, this practice of having multiple constructors is called overloading the constructors. And all that means is you have multiple constructors depending on how they're called. So this constructor will be called if you instantiate a fridge with no arguments. You just say new fridge, like we've been doing, like this example. But if you say something like this, new fridge, and you pass some arguments, you pass the model number and the number in stock, then this constructor gets called. Let's go ahead and save it and try that example that I just showed you. So there we go. We've got the model number. So that means that when we instantiated this fridge, it set the model number and number in stock, and then we used our getter method that we added in the last section to read the model number variable. Okay. So that's kind of the basics of constructors. Constructors are just methods that run at the beginning to let us set up our classes. So far in our example class, all our variables and methods have been instance variables and methods. What that means is that these variables and methods cannot be called until a fridge instance is created. So we couldn't just call fridge.updateStock because there's no instance associated with it. We'd have to first create a new fridge, as we've done in all our examples. Now, what if there's a case where you want to have the same value available to all instances of the class fridge? You would use a static variable. So you can use this as an example. What if you wanted to have a stock threshold that was the same for all instances of fridge, and if you changed it, you'd want it to immediately be available to all the existing fridge instances? You'd want to make it static. Static variables and methods exist and can always be referenced without creating an instance of that class that they're a part of. So I can show you, kind of better show you what that means by doing this. So, for example, everything we've done previously required making a new instance of fridge, but now we've got our stock threshold. So I should be able to just do this since it's static and call fridge.stockThreshold. Execute. And we should see 5. There we go. So since that's a static variable, we can reference that just by using the name of the class and see what it is. Now we can also make changes to it, like this. And we'll see those in our debug log here. And if we had multiple instances of the fridge class running on our system, they would all see that change immediately. Static variables and methods are different than the instance ones because instance variables and methods are unique to each individual instance. So that was kind of a neat example of changing the stock threshold in line right here. But what if you don't want it to change? What if you want that always to be 5 and that the program is unable to change it? Then you would want to set that as a constant. Constants are variables that once declared can no longer be changed by the program. That is done by using the reserve word final. So by saying public static final integer stock threshold 5, we're declaring an integer stock threshold be equal to 5. We're saying it's final, so we're making it a constant, so this cannot be changed by the program. We're saying it's static, so that only one instance of it exists across all the instances of fridge, and even without one being instantiated at all. And we're saying it's public, so it can be accessed by other classes. So now that we've made stock threshold a constant, let's see what happens if we try to reference it or even change it. So I do this, it immediately yelled at me. Now that stock threshold is a constant, there's no way to change that value. Now, that's a good illustration of static variables and constants. But what if we want to have a static method? Static methods work very much the same way. I'm going to use this method as an example. Now, this method is called toDebug and accepts a fridge object as a parameter. And all it does is print the model number of the fridge we passed and the number in stock of the fridge we passed to the debug log. And since we're making these references from within the fridge class, we'll be able to do this. So I'm going to go ahead and save this and show you how this works. Now we can declare a new fridge with a model number and a number in stock, and then we'll call toDebug on my fridge, and we should see some messages in the debug log. Model number, number in stock, exactly as we expect. So that's how static methods work. You can add methods into the class that don't need to be instantiated to be utilized. That's particularly helpful with kind of utility style methods. We've already actually used some methods in earlier examples when working with primitives and data types like strings. A lot of the built-in methods are static methods where you can just say string dot and then some kind of method there. So you may already be a little more familiar with static methods than you think. The next thing we're going to talk about are interfaces. Interfaces act as a common blueprint for classes. Interfaces allow you to set a specific requirement as far as what methods are to be in a class, what they're going to return, and what they're going to accept as parameters. This allows you to have a common set of expectations for classes that you implement using that interface. It's kind of tough to describe, it gets a little meta, but I'm going to go ahead and show you an example interface to make this a little more clear. So from the debug console, you want to go up to File, New. We're going to create a new Apex class because it's very similar. You want to create an interface the same way you create a class. And we'll call this Kitchen Utility. And our interface is going to look like this. All this interface does is declare the interface, call it Kitchen Utility, making it public, and it's stipulating that anything that conforms to this Kitchen Utility interface has a method called getModelNumber that returns a string and accepts no parameters. So what we can then do if we go back to our fridge class is we can have it conform to that interface by saying public class fridge implements kitchen utility. And now that doesn't really change anything for us here because we already have the getModelNumber method there. So it already conforms to that interface. Now we're going to go ahead and create a new class to illustrate this a little bit further. We're going to call this new class Toaster. And we're going to have the Toaster class look something like this. So public class Toaster implements kitchen utility, and it's got a model number, and its getModelNumber method returns a string, accepts no parameters, so it conforms to kitchen utility. But for toasters, whenever you get the model number, it's going to append the letter T to the front of the model number. That's it. So what makes the idea of an interface useful is if you have a set of classes that all conform to a given interface, you can write other code and make assumptions based on the interface. So, every class, say we can add a class called microwave, and as long as the microwave class adheres to the kitchen utility interface, we know that it's going to have the get model number method available, and we can use that to read the model number out of an object. So interfaces are good because they allow you to create templates and higher level abstractions of your classes so that you can keep your design and your implementation even more separate and keep things cleaner and more consistent. In addition to helping you maintain your consistency in design, using interfaces can also really help simplifying implementation. I'll show you what I mean by this. So in this example, we're creating a new fridge called F, setting the model number and the number in stock. Then we're going to make a new toaster. And now we're going to create an array of kitchen utility objects called utilities. And in that array, we're going to put F and T. And then we're going to get the model number of the first object in the utilities array using their get model number method. And then we're going to write that to the debug log. So we should see MX in the debug log if I run this. Let's go ahead and do that, make sure that works. And I'm going to explain that a little bit deeper. All right, so that worked. So the major benefit of having the fridge and toaster both use the kitchen utility interface is now we can treat them as almost the same kinds of objects if we want to get the same kinds of data from them. So if I wanted to write a chunk of code that all it did was get me all the model numbers, I could just treat them all as a group of kitchen utilities and not have to worry whether it's a fridge or a toaster, because what I'm looking for is common between them because they share a common interface. The last thing I want to talk about in this tutorial is property syntax. Now, we said properties are the get and set methods that we associate with private modifiers. So in our example, we already have get model number and set model number. We consider these properties. Now, because get and set methods for private variables are so common, there's actually a special syntax just for defining them. I'm going to show that right here. Now here we're declaring a public integer called eco rating, but what we're also doing is we're defining code for get and set, which corresponds to when the variable is read and when the variable is written to. So even though this is treated as a public variable, we've associated code with it to verify and process the values very similarly to what we would do with, for example. So, by declaring a variable this way and using this property syntax, it allows you to use direct references to the variable like you would any other public variable, but you still get the ability to add code that manages the get and set functionality to it. So it's kind of the best of both worlds. And I can show you that with this next example. Let me go ahead and save it. So in this example, we're going to create a new fridge, set the model number, set the number in stock, and then we're going to set the eco rating. And in this example, we're setting the eco rating to -5. And now this doesn't simply assign this value to this variable, it calls the setter. So it passes this to this method right here. So we get eco rating is equal to value. If eco rating less than 0, then set eco rating to 0. So comes in, the first thing that happens is this -5 will get assigned to the member variable. Then it evaluates that if it's less than 0. If it's less than 0, it just forces it to be 0. And then when we do system debug fridge.eco rating, this does a couple of things. We're going to see that the set method did what it was supposed to do. And then this also allows us to make a direct reference to eco rating without having to call like a get eco rating method. So let's go ahead and run this and see what this looks like. We should see a 0. And there we go. So that's property syntax and how you can declare public variables, but also handle how they get accessed. The best features of public variables and the best features of private variables all at the same time. So that's going to do it for this tutorial. In our next video, we'll cover Chapter 2, Tutorial 8, S-Objects and the database. Thank you for joining us. For more great content, click to subscribe to us on YouTube.